So we will go to the face recognition first, then after that emotion will be there. Okay. Can turn off this light better. These two lights we can off. Yeah, then it will be clear. Yeah, now it's good. We wait for 2-3 minutes and we'll start. Were you able to log in and open up this one? All right. So during last lectures, we were able to do the object detection model, right? So we learned how the object detection works uh, compared to the image classification. Image classification means you upload one image and say what is it. That's all. So, for example, if you train the model, okay, let them come. Yeah. So when it's come to object detection, sorry, image classification, let's say you and a dog are there in an image and you train the image for dog, right? Classification, it will say dog. But if it's in object detection, it will say a person is there, a chair is there, a dog is there. In one image, it will be able to do this thing. So how it do? How it does? It scan through the image through a box, right? So we have seen it will find out the objects and it check whether that object is already trained over there in the pixels, right? So there are multiple data set available for that kind of object detection model. So we have trained one for vehicle detection last week, right? Similarly, there are famous data sets called COCO data set. So that means in an image, they were able to classify chair, table, everything, right? So there are millions of uh, data were included into the COCO data set. So typically when it's come to YOLO, so they use the COCO data set for the training for general purpose. So if they want to detect a car, van, chair, table in a room or something, then they use the COCO data set because it has all the data set available, right, for the object detection model. But if you want to specifically train a object classification or object detection model, so you know how to do that. You go to the RoboFlow, collect the data, box those specific items and label it, then you do the training, right? So that's what we have performed during the last lectures. So first we will do the face recognition. That is the last week, second lesson. So were you able to log into the last week yet? Yeah, right? So then you can go to the face recognition. So today we are going to learn about the face recognition. So face recognition is everywhere these days, right? So for even where I go to the gym, they have a face recognition system, unlocking system. When I go, it scan my face and it detects location and the door will be open, right? And the Facebook, if you post an image, and it will be able to find a person who are in the image, right? How it does? So all through face recognition, right? So the first step to recognize the face, what do you think? What should be the first step? The first step should be identify the face on an image, right? So how we have identified certain objects in an image last lectures? We have trained, this is a car in an image, this is a van in an image, this is a lorry in an image. Similarly, we can do it in two ways or multiple ways. I would say like 3-4 ways are there. So one thing, you can train a model only targeting the faces, right? Take an image of a classroom and I'm going to train the model face, 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 like that. All the faces I'm going to box it and I'm going to train the model for face detection, right? So then the object detection model will be able to detect the faces in the image, right? So once the face is detected, then we can go for the recognition path, right? So when it's come to face recognition, there are certain libraries already in the Python. So we are not going to train a model this time, right? So they have trained a model and they have kept it over there. So it's not like a CNN based thing. CNN based thing mean what? So you collect the faces, like if me, Logi faces like 100 images of mine in different angle, different poses, right? And 100 image of you, and do the training and build up. So what will happen if a new person come to the gym? So you want to take an image for 100 times and say, okay, retrain the model. Oh, it's costly, right? It need to take a long time to do the training again. So it is a infeasible option to do a CNN based face detection, face recognition, because any new employee coming to office where the office has a face recognition based entry system or no. So you can't do that CNN based thing in that case. So mostly what they have done is they have trained a CNN based algorithm, right, to extract the features from the face. Right now, what we are going to do is, okay, a new guy is going to come to the gym or to this SIST. So what we will do is we take an image and there will be a face detection model is there. It will detect his face and the face will run through a CNN based model, which is a pre-trained model, which is embedded into the Python library system. So now what will happen? That face feature extraction model will analyze the face and extracts all the features automatically, right? It's a pre-trained model. So now for me, if I upload a face, it will detect from here to here, here to here, here to here, 128 features, right? 128 features. Then it will save those features as a matrix, right? So that is the only thing that we are going to do. So when another person come in, so next day I come in, the camera will take a photo, detect my face, and extract the features. And already I have extracted the feature and saved that features as Logi, right? So when the new feature comes and it go through all the features and try to match it, right? Try to match it. So where the my features and the already saved features matches more, it will predict as this is Logi. So this is how going to happen in the face recognition model. And you can always try to detect the face recognition model in the traditional way, CNN. So you collect images, train the model and keep it. If there are a fixed number of people in that, there is no people are going to leave, there is no people going to come and join you. So, but in real practical, that's not the case, right? So even the Facebook, if you imagine today itself, when I'm talking now, there are thousands of people dealing with photos, uploading photos and everything. New faces are going to be there. So collecting all the faces, detecting all the faces, training using the CNN. Do you think Facebook is capable of doing that? No. It's GPU powered thing. So those are costly. So to avoid those stuff, what we are going to do, a different, right? So that's the thing, facial feature extraction using a CNN model and comparing the features. So that's what we are going to do in today's lecture series. Okay. So this is a traditional way and more or less, this is more accurate in face recognition. But there are certain facial features. I said CNN based facial feature extraction library, right? There are many libraries available like that. So in that case, we are going to use 128 features or something. But there might be 1,000 features also a CNN can do, right? So that depends. So did I told an example? In one of the gym when I went there, my brother's face is detected as mine. What is the reason? Because extracted certain features, they might use a less number of features. 64 features extracted from the feed. So the 64 features my brothers has and I have, more or less it's the same. Then it say, okay, scan my brother's face and go through all the saved features and identify best match. And it found out my brother has a best match compared to my face. So it detected as my name. So it cannot also not happen, right? So maybe they might use less number of feature extraction because it should be faster, run on a CPU. Obvious, the hardware requirement is less in that case. So in the gym, you can't expect a high-end model to perform the feature extraction because they need a GPU and everything. So it's a very simple tool. Maybe 5 features or 10 features they will extract and map, right? So depends. So today we are going to use a library called OpenCV, right? In the Python, OpenCV. OpenCV is a well-known library for vision tasks. All the vision tasks. Image, when it's come to image detection, image classification, OpenCV plays a major role in Python for image or vision related tasks. Okay. So we are going to use the OpenCV in this face recognition tutorial. So as an example, as I said, you can see when you upload immediately, it identify Rebecca. You want to tag Rebecca in this photo. But when you upload a photo, right? Then when you tag a person, it will not say next time when you upload the person, right? Couple of time if you tag the person only, later on it will be able to identify this is this person, right? How it happens is it detect the face, save, extract the feature, save it in the database. So when you upload a photo, immediately it go and detect the faces, match through the database, feature database, and identify who is the extract person. It sometimes misidentifies as well in the Facebook, right? I have experience when I uploaded a photo, a different person name is mentioned as a tag. It can happen because the facial features can match, right? If it's a twins, definitely there might be things. Common features are there, identical twins. So we have to be very careful in that case. So now if you see these two people, for the first time without the beard, these two people look the same for me, right? For my human, but those people are totally different. So when we put it into the feature extraction, maybe his mouth is little bit looking different compared to his mouth. So the angle from here to here, the certain features will be different, right? So we will see how to do that. So how the AI do that? Yeah. Same thing. Same thing. Not, yeah, we are going to use only one photo here. That's why I said CNN based training, deep learning based training is not going to be feasible in the attendance system because you have to go for a photo shoot. A new employee, 100,000 images need to be picked in order to identify the features from you. So it's not feasible. So they just take 1 or 2 photos and upload it to that system and it automatically embed your feature into the database. So that's what we are going to do today. Okay. So that is the feasible system for face recognition. Even Facebook is doing and everything. Even your mobile phone face detection. Does it use 1,000 images scan? No, just 1 image, 2 images. It will be able to detect, right? So that's the thing. What it does? Facial feature extraction. The facial feature extraction library in Python is a CNN model, right? That is a CNN model. So we are going to use that library to extract the feature. We are not going to do any training in this session. Clear? Okay. So what it need to do is, first it need to look at the picture and find all the faces in it. That is called face detection. Second, focus on each face and be able to understand that even if a face is turned in a weird direction or in a bad lighting, it is still the same person. Third, be able to pick out unique features of the face that you can use to tell it apart from other people. Like how big the eyes are, how long the face is, how the eyebrow shape is, how the nose shape is, everything. All these features. Okay. So finally, compare the unique features of that face and the photos features and map who has the closest match. That's all. Right. All right. So here sometimes you can see the faces in here. You can see here is as an eyes, there is a nose, and there is a mouth. If you take it as, you can see it as a face, right? So in face recognition model also, in the face detection models, sometimes this system will be identified as a face, right? So if you take a photo, if you have two buttons here and three button here, it will put a box as a face. I'll say why is that happening. Okay, even in this tutorial, sometime you might encounter one face and two face in your t-shirt. So why it's happening, I'll tell. It's not using a deep learning based face detection. So there are two things we are going to learn: face detection, face recognition. Face detection is the first thing. Based on the face detection, we are going to use the face recognition, right? First, the face need to be detected. So we will use that thing. So the first step is finding a face in an image, analyze the facial features, compare against the known faces, right? That we have trained for, then do the detection. This is a simple procedure. No training at all involved because we are going to use a Python standard library called OpenCV. OpenCV. You can use Python anywhere. This is embedded into Python, right? It's a Python library, right? All right. So we will start the face recognition step by step. So in this tutorial, we will collect certain faces. Maybe I'm going to use a face from maybe SIST staff faces or else certain faces from the online. So I will use certain faces from my department, right? And we will do the train over here, right? So how to build up an attendance system, we will train. So first of all, we will start by connecting our Google Colab to our drive because we are going to save certain information. To save certain information, we will connect to the drive. So you know the drive, right? Where the drive is. So if you go to the Google here and let's say Gmail, gmail.com. Say here you can find the drive. So it's a data storage elements in our Gmail, right? So this is the drive. I have all my drive over here, whatever the things I'm going to use to connect to the drive to save the data. So by executing this column, so drive mount, content drive and base path, I'm going to drive mount to the drive and load the drive over here. So by clicking it, right, you will be able to connect to the your Gmail drive. Okay. Now I'm connecting. To connect, I need to give permission. Right? It will ask for permission. Then when I go there, I connect. So I'm going to connect this Gmail account. Continue. Then continue. Then the connection will be made with my Google Drive. Right? Just click it and give the permission. So why we are doing? Because we are going to deal with the data. We are going to store all the data over there in the drive directly. So that's the main reason. Take few times, few minutes, because based on your drive size, it will take some time to load and put it over there. So run and connect to your drive. Give permission, continue, then you will be able to connect. Did it connected? All right. So once it drive already mounted that content. So once it mounted, you can see the drive over here loaded. So you can close it and open it up. You can see the drive is mounted. My drive is there. And all these folders, whatever the things all are here. Right? Okay. So after that, what I'm going to do is I'm going to create a new folder. Right? I'm going to create a new folder called face recognition to save all my data over there. Right? Because I need to have a database because I'm going to upload a photo of a person, right? Photo of a person. I'm going to send it through a CNN model, which is going to extract all the features and it's going to keep the matrix number, all the features as a matrix and put my name. And this should be in the database, right? So when I come next time, the camera will take my photo and send through the CNN model and extract the facial features and compare these features with all the data in my database. So I need to have a folder for that. So I'm going to create a folder inside my drive for that purpose. Okay. So by executing the second thing, there will be a folder created under the uh, Google Colab notebooks. So let's execute it, right? So once you execute, you'll be able to go and see. Were you able to mount it to your drive? Okay, cool. Just execute it. The internet is unstable. It will be an issue. Okay, let's see. So face recognition, for me, it's called as already exits because the reason I ran this thing last night to check whether everything is working. So it got created. So let me delete that one. Then we will be in the same page all the time. Okay. So let me delete that one, my drive. Okay, Colab notebooks. I'm going to delete this face recognition. Okay. Move to trash. All right. Now I'm going to go back to the Google Colab and I'm going to run it again. Yeah. So now if I run it again, folder face recognition created successfully. This will be the message that you might get, right? Did you get it? So once you go to my drive, Google Colab notebooks, you will see the folder created over here, right? You can see, go to drive, my drive, Google Colab notebooks. The face recognition folder is created over here. So we are going to store all our data into this face recognition folder. Clear? Okay. Were you able to create the folder now? Okay. So now let's start collecting the images, right? So we need to collect certain images and we need to upload it to the image. So for that, what I will do is I'm going to go to a place and I'm going to search UOM. You can also go follow me. We'll select certain faces and we will upload and test it. Okay, UOM, maybe, oh, maybe SIST staff. SIST staff. This is SIST, right? Yeah. STAF. Okay. SIST staff. Or SIST. Spectrum Institute of Technology. So we will go and find out certain people faces over here and save it. Then we will be able to test it. Okay. So first we are going to create an attendance system for the SIST. So let's find out the people. So we'll go to about page and local faculty. Maybe see who are the people over here. I couldn't find the people. Huh? We don't have? Okay. All right. So then we'll go to EUON, right? So we will collect random photos here. So we'll go here, go to the website and people, academic staff. So this is my department. So I'm going to collect Professor Cecil's tomorrow, this photo. I don't want to collect others people because it's ethically not good to use others photo. Professor Cecil is partner of this course, so we will collect his photo. Okay. So we will go save image as, right, and downloads, and I'm going to say Prof. Cecil Kumar Vadu. Okay. So I'm going to save it as a JPEG image format. Right? Don't collect others' photo. Okay. JPEG. And you can go and collect mine here. Right? Save as. Save image as location. Okay. In the downloads folder, JPEG image format. Two of them is fine. Then we will come to back to maybe, let's say, Paras photo somewhere. We can. Nope. What's his UTIT? We'll see. Okay, we'll see ETIT Dubai. If you type it, it might go to yeah. Here we might find Para's faces. We'll see. Para is there. About us. Research. Para is not there. Research. Chandra. Oh, we can get his photo. But Chandra. Okay. We'll go to this site. ASCII dot AI. Right? Okay. There we can use the photos to trade. No, save it in your download folder. So we will upload that later to the drive. Okay. Or wherever, save it in the desktop or wherever, we will upload it later. So now we will go to the About Us page. And here where we will be able to find the people information. Right. So also I couldn't find our people. Do you know any other places you can download? Let me see. Mm. Okay. So we have two photos. So I made you to take your photo as well in a column. So you don't want to save your photo now. So we will find some other people photo over here. About us. It's not here even, I don't know. Okay, so we will go, we'll come to SAST. Okay, SAST and we'll find some more people. I found Jay's photo somewhere. Story about us. Here we go. All right. So we will save Jay's photo. Save images. Okay. Mr. J. Okay, I'm going to save it in download. And we'll save her photo. Miss Gauri. Save image as. Save. Yes, Gauri. Then we will save this guy also. Who is this? He is Gary, Mr. Gary, or Professor Gary. Save image as, yeah, Prof. Gary. Save, and we will save this guy also, Dr. Amia. Save image as Dr. Amia. Loads, okay, save. Cool. Okay, so now we have collected certain images to do the facial recognition model, right? So now we'll go back to the Google Colab. Okay, so then we need to change this. So how many number of people we are going to add into the system, right? Now I have added as 3. So let's say I'm going to add now 5 people. So I'm going to click 1, 2, 3, 4, 5. Yeah, I have 5. No, 4. 1, 2, 3, 4, 5. 5 photos. Okay. Then I change it as 5. Then I will play this one. Okay, execute this code. So now what we need to do is we have to upload the images to the drive. So I'm going to say first Prof. Cecil. Cecil Kumaravadu, right? The ID name. So his name, I enter. Then I need to choose his image over here. Choose his image. Go there and into the downloads. You can put it in the small icons format, maybe medium icon size. Okay, I'm going to upload Professor Cecil over here. Cool. Okay, it's got uploaded. Then the second ID, I'm going to add as the other image, whose image, Mr. J. Mr. J. Right? So I'm going to go upload Mr. J's image now. Then the third one I'm going to add Miss Gauri. Gauri. Okay. Then go there and I'm going to choose file. I'm going to add Miss Gauri's image for that item. Then other guy is Professor, who is that guy? Professor Gary or someone, right? Second, Prof. Gary. Prof. Gary, right? Okay. Prof. Gary. Prof. Gary. I'm adding it. Choose files and Prof. Gary. Right? Cool. Then after that, I have added 1, 2, 3, 4, one more, right? So he is Dr. Amir. Dr. Amir. So I'm going to upload his image into the system. So we have actually collected 5 people's images and we have added to the system. Have you done it? All the 5? You have done 4. Okay. It's fine. So for you, one of my image will be there. Yeah, so you can add that, right? Under mine. Because I will take that photo now. Second, you can take your photo by executing the next code. So that's why I didn't upload my image over here. Okay. So once you uploaded all the images, second we are going to do my code. So to do that, there is a huge block of code. So you have to execute to take the photo. So if you go through that, import operating system, we are importing all the libraries that we need to take a photo from the Google Colab. And these are the JavaScript to access the webcam. So you don't want to worry. Even I don't know what is inside, right? It's a JavaScript, standard script. So I use upload it over there to get the video access over there, nothing else, right? So now by executing code here, it will ask the ID. So this is me. I'm going to say login. my name. You have to enter your name. So once you enter, the web camera will be turned on. And it will ask to allow web camera, right? So you have to click allow. So once you click allow, then you can see your image over here. You see it? Then click capture. Once you click capture, and these images will be saved to the drive. It's also saving here, it doesn't matter. So come here, you go to the face recognition. You can see Dr. Amia, Logi, Jay, Gauri, Gary, Prof. Cecil Kumar. So if you go here, their photos are there, JPG. Right, Dr. Amia's photo, you can just click and see his photo is over here. Cool. All right. So now we have uploaded the photos. Even my photo, which I took through the webcam, it's stored over here as log. So you can see the take photo I took, it's saved over here. All right. So now we have collected all the faces for the face recognition system. Or clear? Have you done it up to that code? Took a photo and save it? You done it? Done? What happened? Webcam is not accessed. You have done it? Took a photo and saved it? You have uploaded all the we have to upload my image over there. There are three images I can very class for the second uploaded. After uploading three, execute the next code, it will take your. So now we have collected all the images for the attendance system, let's say, that we are going to build, and we have done. So now the first step, face is there. All the people images are collected. So for the machine, to identify the features, we are going to collect the face detail only, right? So we have to detect the face from that image. Detect the face. So how we detect the face in an image? How we detected the dog on the image? How we detected the car, van on the image? Through object detection mechanism, right? Through YOLO. So how we trained? We have a road image. In the road, there are a lot of vehicles. We label this as car in the RoboFlow, and we train the model for the object detection. Similarly, also we can do only label the faces, box the faces, and we can train the model to detect the face. One day. But the problem is that requires a lot of effort to do the data collection. And after you train the model, it will take some time to do the face detection. Because it's a CNN model, the image need to go through the CNN model, it need to detect the faces, it takes a little bit of time. And the YOLO model is really heavy. It's a heavy CNN model, right? So now the issue is, if the Facebook is using that one, so you upload the photo and wait for maybe 2-3 minutes for the Facebook to detect the faces using YOLO algorithm. If they are using it, then only you will be able to do the face recognition. First, it need to detect the face, right? So imagine if your attendance system is using YOLO to detect the face, what will happen is, you go take a photo, go and have a coffee, coffee and come back, it will detect the face and recognize. So it's not practically feasible, right? So we need to be very quick. So for that case, there is a mathematical algorithm is built up, right? So that is called this one. What is that? Haar cascade method. Haar cascade classifier. You can see it over here. Haar cascade classifier. So the OpenCV library actually uses a Haar cascade classifier to detect the faces from an image. To detect the faces. So how it does? It does through a mathematical way, right? Do you remember we have done some thing called kernels? Classic CNN layers, convolution layer. We have done some convolution mathematical operation. So there is a filter, move through your image, and the output is saved as a second, right? That is the kernel. In the fifth lecture, we have done it, right? Convolution. Even in the third lecture, we have talked about convolution. So the convolution, you send a filter through the image, pixel by pixel, and you save the relevant image. So now they came up with a filter like this. This is a filter, B is a filter, C is a filter, D is a filter, E is a filter. So these A, B, C, D, E are, this is 1, this is 0, 1, 0, kind of dark line, 1, 0, 1, 0 values. So what will happen is, so this is the example. Okay, first filter, second filter, third filter, fourth filter, fifth filter, sixth filter. And the relevant values will be put over here. You can see this is the image. These are those filters moving around the image and putting the corresponding values. So these first 6 values are different filters went through this image and saved the relevant values. Kind of a convolution. Convolution means same filter go through the image pixel by pixel. But this is different filters go through different that same pixel and save the image over here. Then this will be moved to next and the next 3 will be determined, right? So this filter arrangement is going to move through your image and going to save the new values into the integrated image. From this integrated image, right? What is that? It should load. It's not loaded over here in my page. Let me see. I'll copy that and put it over here. Then you will be able to see that one. How it's actually happens. Okay. Okay. Is that the wrong one? Okay, let's type face detection using Haar cascade GIF. Right? So I'll go to the image and you can see how it works. This is a GIF image. Here, see, you can see that. Right? This is the image. Its internet is very slow. That's why it's getting loaded. Yeah. Okay, let me see. Maybe this one. So what it will go is, this is the filter. It will go through the whole image. When it's going through a certain image on top of the face, actually the face will be marked because of the filter numbers. Only the face will be extracted, right? So you sharpen the image, you increase the green color, you reduce the green color in an image. So those are filters, right? So like that, when you run, see, this is the one. So like that, this filter is going to go through the face, right? And this resultant value will only extract the facial thing, and the face will be detected. This is much, much faster than a YOLO trained face detection model, right? So it just go through the filter, finally the face will be detected. So that is the method this OpenCV is using. So do you think the face recognition system came after 2017 only? No way, right? It was there since 2001, 2002 face recognition system. So at that time, we do not have the YOLO algorithm at all because the GPU is not that famous at that time, right? So how to detect the face without a CPU, GPU? This is the way. So you have to simplify the operation. So that's the hard cascade method. But if you ask me whether it's very accurate in face detection, no. The reason, if we see two eyes in a nose like that in a feature, even in a t-shirt, it will put a face box over there because it identifies the output as a face, right? So this is just a mathematical operation, okay? So we don't want to do too much. So when an image comes, it scan through the image, the filter will move one by one, scan through the image and detect the face. So this is the face detection mechanism that we are going to use in this Haas cascade method, okay? Is that clear? Just a mathematical operation, go through this and detecting the face. Cool. Then after that, what we are going to do is, we will detect the faces from the uploaded images, right? First, we have to detect the faces. So by executing this code, you will be able to detect the faces. So now what is happening is, I am using a import CV2. Import CV2 means this is the OpenCV library that we are going to use. OpenCV library or import CV2. Then if you see, face cascade is equal to CV2.cascade classifier. So that is the Haas cascade classifier that I have used over here to detect the face. But there are many other classifiers available in the library, right? So this is one method. There are multiple other methods available. So I'm using Haas cascade. Now the Haas cascade means running through the image and putting the values over here, and the face features value will be extracted in this image, and it will put the box around those values. That's all. So now if you execute the code and go here, you can see Professor Cecil Kumar Avadu's face is identified, and Amiya's face is identified, and who is this? Mr. Gary's face is identified, and Logi's face is identified. What happened to Mr. J and Ms. Gauri? Their face is not detected from the image. The reason, Haskett case went through that, due to the lighting issues, it couldn't identify the face, right? That is the main reason. So the cascade can detect the faces, or else it won't detect the face because it's just a metric multiplication, go through your image. If it couldn't identify the face by multiplying those image pixel, it won't detect. So lighting is an issue for the cascade. So in Mr. J's and Ms. Gauri's image, it couldn't detect the face, so that's why it didn't show. But Professor Cecil detected, Professor Gary detected, Dr. Amiya detected, and my image is detected. So now this is done. Face is detected. After the face is detected, what is the next step? We have to extract the features, right? What is the feature from here to here, here to here, here to here, here to here, here to here? All these features need to be extracted. So we are going to use again a face recognition OpenCV based library. To do that, we install certain dependencies. So we are going to install the OpenCV headless, NumPy, and face recognition libraries. So these is dependencies into the platform. So this face recognition library is a CNN based library, pre-trained model, which is going to detect the features from your face. So it's a CNN model. You send the face, the features are extracted. That's all. Okay. So the Haas cascade method, two ways. It can fail to detect a face due to the lighting, because you can understand it's a metric multiplication. Go through that, face is not detected. The output image couldn't identify the face. Therefore, the face is not detected. In certain images, yesterday I took an image with a t-shirt on something here. It took my photo and detect this as a face as well. Why? It go through the whole image, identify certain features similar to a face, it detect as a face. So that is NP2 in this system. But if you use YOLO, it will do it. Right? YOLO is good in object detection. But the problem, it needs GPU and it is very slow when it's come to process. Right? So, but accurate. Fast cascade, very quick. You see how it done. Once we click it, immediately one to one the face, very quick. Right? But YOLO will take a little bit of time to do the detection. That's what I say. If you have a CPU, implemented the YOLO algorithm for your attendance system for the face detection, you come, take a photo, go and have a tea and come back, then only the face will be detected. That much slow. So we don't want to do that. We are going to use this system. So now we have installed all the libraries that we want. Now what we are going to do is, we are going to go to this thing and we will extract the important features. So for that, I'm going to do face encodings. Those features are called as face encodings, right? So by getting the feature, angle between this to this, I also don't know, right? What are the features? But 128 features for this particular line. So if you want to run more, different. If you take an iPhone, it has thousands of features. iPhone face recognition, it's not just that image. They send an IR wave onto your face and there are point cloud, lot of points extracted into your face, and all these features are extracted point to point, point to point, point to point, right? It's not the photo only. So they get an IR image of your face. So I can show you here in the Google. So iPhone face detection. So like that, see, like this, your face, the IR signal will be shown to your face, and there are a lot of points concentrated over there. So those are the values here to here, here to here, here to here. This matrix is the one the iPhone is using to identify your face, right? So not just the image. So if they use just the image, security is an important thing, right? If they use just an image, I take an iPhone, show my photo, it will unlock. It unlocked early. It unlocked at the previous versions of iPhone when it's introduced. Some Android phone came from China, had the Facebook face recognition. When you saw the photo, it unlocked because it just took the photo and identified the features. It's just a 2D. But this one is a 3D. So you can see how the 3D mapping. So here the light intensity is low in this part because you are taking and the light IR wave is posed to the face and this light. So it analyzes the depth also. So you can't show a photo and unlock an iPhone because it gets a 3D mapping. 3D mapping, right? But certain experiments have been done. They made a person's 3D image. 3D image. And they make a clay type of face of him, exactly looks like him, and put it into the iPhone and try to unlock. It didn't unlock. It did the same technology, exactly look like a person, look like the face. It didn't unlock. The reason, one thing, maybe we don't see, we see it as the same person, but the IR, there are microspots, see microspots. So those lens might be different, right? So this lens might be different. And the other thing, this is an IR. So that means it reads the temperature as well, whether it's a human or not human. Right? If the temperature is not 37, 36 degrees, it identifies as a different object. So there are multiple techniques. So iPhone face recognition feature is really advanced, really advanced. Not just take a photo and do that. But Chinese iPhone earlier came in 2012, 13 time. It was a new feature, but if you put a photo of mine, it will unlock. So less safety feature. So the same here in your office, you put your photo, it will unlock. Because we are going to do the same here. That's the thing. Because these are advanced features when it's come to the face recognition system to avoid these issues. Okay. So now we'll
happened recently Sri Lanka and they fixed the system in the airport to recognize.
Let's do the same thing. Let's do the same thing that we are doing. It do the same thing, but they use a different face detection and encoding mechanism. So our thing, you see, two faces are missed in the hash code, right? It didn't detect, but they might use a different high advanced algorithm to detect the face. And face encodings, here we are going to use little bit less features. They might use many features, right? So that's different, right? But the same way, same technology through the face encoding mechanism. So now what we will do is we detected the face. So now what we will do is we will extract the encoding from those faces. Okay, we go through that, and it might give an error message because of Mr. J and Gauri's face is not detected. So we'll see. No, it's ran. So now it extracted all these encodings because I used this library called face locations, face recognition. So this one, face encoding, extract face embeddings for the first face form. So whatever. So face encoding, face recognition dot face encoding. So this is the library which is going to extract all my features, right? So I ran. So then let's see what are those features I have identified. So if you run it, so this is the face embeddings for CISIL 7, right? So you can see a matrix over here, right? You can see a matrix over here, minus 1.4531 something, right? For CISIL 7. The first value is this one for Professor CISIL. If you come to the second, right? Gary, it's a different value. See, right? And if you go to Dr. Amia, it's a different value. So now if you go to me, it's a completely different value. So obvious, right? From here to here, from me to CISIL sir is completely different, right? So that's how now we have differentiated this embedding. So it's a CNN based algorithm. Without you connecting to this T4 CUDA, it won't run. If it's not only CPU, this library won't run because it's need the GPU to run. It's a CNN based pre-trained library. You send the face, it give you the embeddings, right? So now we have extracted the embeddings as well. Clear? Cool. So now we have saved these embeddings into a folder. So now we will say, we will take an image and see whether it detects my face or not. So you go there and you capture the image. I'm going to go a little far, maybe here, and capture an image, okay? Let's see. What is the results? So I train, it's a logi, but now you have to be careful. It says Professor Sisil Kumaravadu 34.41. My feature matches with Sisil sir feature embeddings 34.41%. Write the values. My embeddings values, Sisil sir's embeddings values are 34.41 match. Prof. Gary 14.78. Right? And Dr. Amiya's 37.51. And Logi 73.36. Then it says Logi. Right? Then your door will be open. You can walk in. Right? So that's how it works. The good thing here, if you see, Sisil sir is an Asian. Prof. Gary may be a UK based guy. Less embed features. Dr. Amiya, definitely he is a Asian. Right? From the face itself, we can identify. See, he should be an Asian. So for Asians, the embeddings are somewhat low. So that's why when you go to abroad, they can easily identify you are from Korea, you are from India, because our faces having certain embeddings in it. Right? Certain embeddings, not the exact, but 34% myself and Cecil sir matches. Dr. Amia and myself matches 34%. How come? Because we are Asians. We have a certain features same. So if I go to US, Cecil sir go to US, they will be able to identify simply, are you guys from India? They don't much know about Sri Lanka. So they recognize as Indians in US. So we say, no, we are not India, we are close to India, next southern part. So they ask, even you are a part of India, all because of our color is one thing, other thing is our facial feature. Can you identify a Chinese easily? Of course, right? You can identify a Chinese. Can you identify a Korean? Definitely. Can you identify a Russian, Italian? Yes, I can, because they have a facial embedding features common. That's the reason myself, my photo got a higher matching compared to Cecil sir and Dr. Mia compared to this Prof. Gary. Prof. Gary is a white guy. He's a UK based guy. His facial feature is different from an Asian facial feature. Clear? So now let's upload some photos and see how it identifies. So what I'm going to do, I'm going to go to something Cecil, Professor Cecil Kumar Avadu's different photo. We'll go maybe this photo. Maybe this also. Okay, this is a young photo. Let's see how it works. Okay, this is a young photo of Professor Cecil Kumar Avadu. I'm going to save image as. Okay, and I'm going to say Cecil Kumar Avadu down. Or maybe I'm going to say test. Test 1. I'm going to say test 1. It's a PNG image. Okay, that doesn't matter, I believe. So go there and I go to the code back and I play it and I need to upload the photo, choose a file. So I'm going to upload a photo, this one. Let's see what's the value is. It's analyzing. See, it's identified as Cecil Kumar Avadu, but 59.61% less. Why? The photo that I have uploaded of Cecil sir is this one. This one is a side photo. At the same time, it's a little old photo of him. This is how he looks like now. But I have uploaded a young photo of him. It identifies because the face embeddings won't change much, even you getting older, but the angle is different. That is, he is looking like this. He is looking like this. The angle is different, but it correctly identified as Cecil Kumar Avadu. Logi 36.51. Dr. Amia 26.41. Why? Because we both are Asians. And Prof. Gary 4.66. Now you identify how this face recognition works, right? In Facebook and everything. So certain times in the Facebook, the tagging option will give a wrong option to tag. Because your embeddings, the person's embedding matches with someone else's embeddings over there and it say, okay, this is the, it's clear right now? So this is how the face recognition works in the real life. But there are multiple ways. CNN based face recognition completely possible. Why? Because you can collect the photos if there is a security zone, only 100 people are going to work for next 3 years. So you want to have a higher security entrance. So then the best way to do is CNN. So you collect my photos, 100 images, and you train them on. Cecil says 100. You are 100, maybe 1,000 of images in different angle, young, with beard, without beard, and everything. Then you train, the AI will detect more than this accuracy. It will say 98% Professor Cecil, right? Because it's higher security zone. Here, it might miss. As I said, 128 features we have extracted now, embeddings. If you go for 1,000, it will be more accurate, right? If you go 10,000, it will be more accurate. Facebook uses more than that. Sorry, iPhone uses more than that. So it's based on the embedding numbers, right? So how many features you are extracting for a face? If you increase the embedding library, CNN, that right now I'm using 128. If you use a higher number of embeddings, this might getting lower. Logi might go low a little bit. Dr. Amia might go a little bit. And Professor Cecil Kumar Avadu will go higher because the embeddings are higher. Let's try another one. I'm going to execute another thing. And I'm going to upload a different person, none of the list that we have done now, right? I'm going to go here. Maybe I'm going to upload this image. Okay, this is an image that we have took in place. Myself, Cecil sir is also there. So it's not detected, no face detected in this image. Okay, that means the hash code encoder doesn't work over here. Let me see, maybe this one. This one will work, I believe. Okay, so it's worked. I'll show you the results. Okay, so now these are the faces detected. Okay, so this is not me actually. This is Dr. Harshal, but it identifies as me 51.75%. Right? I'm not there, but it's detected my features and his embeddings are matching 51.7. Right? So this is what happened when I went to the gym. My brother got the same features as mine and he got access to log into the gym. Right? This is again Professor Cecil detected, Logi detected, and these two again detected as Professor Cecil. They might have certain embeddings which is closer to Cecil, but not exact, right? So this is the problem. So here if you see 27 Cecil Kumar Avadu, Logi 37.45, okay, it says Logi. The other one, Professor Cecil Kumar Avadu, 63.41. So it detected Professor Cecil as Professor Cecil. And going above, and it detected that it's detected as certain 34, Dr. Amia. This person as Dr. Amia, kind of looking same, right? This guy and Dr. Amia, kind of same features, but less percentage. So what we can do for this false detection? Put a threshold. If the detection percentage is above 75 only, allow this person, or above 80, allow this person. So this is a general image. This is a general image. But in an attendance system, you are going to face the camera. So it will be 100%. For example, we have done the testing. So it detected mine as 73. So you can put the threshold. If it's above 70, then allow, or else less. So if you go here, the first feature is Dr. Harsha detected as 36.80. But it puts Cecil Kumar Avadu over there in the photo. But it's not. If I put the threshold, none of the faces will be detected. Right? Identified. So here 61 Logi, kind of okay. I'm detected as Logi 61. But still, it's not above the threshold. Right? So we can play with the threshold in that same to avoid this mismatch. Right? So now is that clear how the face recognition works? Right? So what we have done, we didn't do any training yet because it's not feasible in the real time. What we have done, we have used this library. What is that called? Face encoding, OpenCV and face recognition. These are two Python libraries. These are CNN based libraries built up. When you put a photo in, it gives the facial features as an output embedded. That's all. So we use that to do the facial recognition. Clear? All right. So now the facial recognition is done. So hereafter you can go and build up a thing. So you can test, show your photo and try to unlock. Sometime it might unlock, right? So the system is not secure enough. So to avoid that, there are multiple other features, CNN-based training. You collect thousands of your images, different angle, and you put it. In that case, this thing won't work. Right? This thing won't work. Another thing nowadays for the facial recognition, they use a 3D cam also. They capture your 3D face and upload it into the system. So in that case, 3D embeddings are there. So the 2D photo won't work. Right? So there are multiple ways coming up for the security measures. Right? Still. So, but the iPhone have the best as I know so far due to this IR feature. Right? You have seen that, right? I showed a photo. So thousands of points, depth, temperature, and all these features will be extracted 100%. So if it's in 120, I take from here to here, here to here, here to here, some features. But millions dots, it concentrated all over the eyes. If you go back to that image, Google image that I have showed you, iPhone face recognition, right? So this face recognition, yeah. See, you can see how many points. Across this ice itself, it got a lot of points. Across this ice itself, it crosses a lot of points. Here, like, it's very hard to fool this system because it has a lot of embeddings, features, right? So you can't fool a face recognition system of a thing. So yeah, these are the things. So many other phones also started to use these point cloud based systems. So once you look at the face, it will be able to immediately, it's IR thing. So when you look at turn on the face unlocking thing, then you can see the IR wave over here. Clear? All right, cool. Okay, so there is a face recognition. Yeah. That is fingerprint. Iris. So there is an eyeball. So it scan the eyes, outer side thing, and in the bowl and the color and that size of that thing and everything is scanned. That is kind of they are using embeddings, but there are more embeddings, not this embedding. This is for facial. So iris scan, they have an embedding system. They take an eye and match these things, features, and do it. My phone have a eye-based embedding system. So I scan into my eye, it will unlock. But if I put a glass, it won't. So that is called iris, right? Iris-based scan. Fingerprint is another thing. You think there are certain embeddings in the fingerprint, it run through that CNN model, extract my fingerprint embeddings, right? Then that is done. So fingerprint-based system is also the same. There are entrance system, you put a fingerprint and do it matches. Basically extract the features from my fingerprint and matches with the available thing. That's all, nothing else. But CNN is possible. You know how to run the CNN, but how many times I need to put the fingerprints? It's not feasible, right? So that's the main reason for that. So now we are going to go to the emotion detection. That is the 7th lecture. So that we are going to train over. Because if I smile, the happy, I'm smiling, right? I'm happy means I'm smiling, my facial feature is the same. When you smile also, I can tell you are smiling. Anybody I don't know in the world, he came and smiled, I can say he's smiling, right? So if a person is looking angry, I can see, I never met him in the past, but I can tell him he's angry. How my brain works? Because the emotion works in a different way. Face recognition works in the brain in a different way. Emotion works in a different way. It's a feature. If a smiling means my lips goes high, eyes close, I can see a happy face. I can show a sad face, even if a person I never met in the past. So in that case, what we can do for the emotion detection, regardless of the faces, I can train a CNN-based deep learning model. It doesn't matter any face. Angry means I can point out any angry person by looking at the face. He looks angry. He looks neutral. He is happy. It doesn't matter which face it is. So therefore, without any issues, we can train a CNN-based model to detect the emotions, right? So is there any different way that I being happy, my face looks sad when I'm happy? No, right? Happy means happy. For all the people, the happy means happy. Sad means you kept your face sad and do that. Angry means your eyes become bigger and you become red and, you know, that angle. So mostly the common features are there for all the humans. So in that case, we can go for the CNN-based model for the training. So that's what we are going to do today in our class. Okay, now we have done with the face recognition. So let me close this one. Go to the AI. Okay, now face recognition is clear, right? How it works? Cool. So now we'll go back to the categories. Week 7, emotion detection. Week 7, emotion recognition or emotion detection. So you click it up, it will pop up and open that emotion detection. I'll clear all these output, clear all outputs. Okay. Then I tested it before. Because what happens in the Google Colab is certain updates won't work in the Google. Even these tutorials are made little like almost 1 year before. So in that case, so what happens is sometimes the library got expired, Google Colab, it won't work. So I need to test it before I come here. Couple of times it happened to me, right? It didn't work that code because of the library upgrade. So before the class, I run last night all the lessons to check whether it's working. Then I come, so I clear the thing. So emotion detection using CNN. Rather than going with the embedding based feature, because it's a phase embedding, emotion embedding doesn't make any sense. Since all the human have the same emotions experience, right? Happy means happy, sad means sad, upset means upset. Like that's how everyone. So why you seems upset? Are you happy? Why you seems to be very angry? So it's common. So therefore, we don't care about the faces. We care about the emotions. Emotions can be recognized in any face. The brain works in a different way to recognize. So the CNN, we can train with any faces, multiple faces, different emotions, right? For that, what we need? We need data. If we want to train CNN, we need a lot of data, right? So rather than taking one face, different emotions, what we have done, we have collected a lot of emotions. So thousands of people's happy faces, thousands of people sad faces, thousands of emotions angry, thousands of emotions different emotions we have collected, and we have a data called FER 2023 2013 FER 2013. Okay, so that data is available in a place called Kaggle. Kaggle is a place where you can find data for machine learning, AI, right? Any data, vehicle data, face data, emotion data, disease data, plant disease data. The people upload it over there, then anybody can access. It can be a private, it can be a public. If it's public, you can download. So in this case, what we are going to use is, we are going to use a Kaggle database for emotion detection, right? So since it's a CNN, what we need to do? Definitely, we need to build up a convolutional neural network with multiple convolution layers and the fully connected layer, as we have done for the character recognition, right? So let's start now. Okay. So FER 2013 data set. So these are, you can see certain faces. So what they have done is, they get an image, detect the face, and label the emotion. So maybe this is labeled as sad. This is labeled as happy. This is labeled as sad. This is labeled as surprise. This is labeled as angry. This is labeled as angry. This is happy. This is sad or neutral. Like that, we can label. So this data set people have collected 35,887 grayscale 48 by 48 pixel images. 48 by 48 pixel images. Why? You can use 1098 by 1098 pixel images, but you have to wait for 3 days for the training, right? You can't do it in the tutorial. For the practice papers, character recognition handwritten, we have used 28 by 28. So to get a little bit extra addition, we have added 48 by 48. A very small image, right? Right? So they have 5,887 grayscale image. Grayscale image means this black and white, right? So now if you see 4,593 images for angry, 554 images for disgusting, 5,121 images for fear, 8,989 for happy, 6,077 for sad. So these are the images that they have collected, right? And they have stored. So if you see, the label for angry is 0, label for disgust is 1, label for fear is 2, label for happy is 3, label for sad is 4, label for surprise is 5, label for neutral is 6. Why? Because we have to do it, right? We have labeled as, even the handwritten character recognition, 1, 2, 3 word, we converted into a number 0 to 9. You remember? So the same thing, the angry, disgust, fear, happy, we have to convert it into the mapping number, even in the object detection, can, when, something. But finally, when we download the data, it's 0, 1 label, right? So that's how it works in the machine learning model. Machine learning model is all about numbers, metric multiplication. So they have given the labels as this one. 0 means it's angry, right? So now we have to download this data. So to do the download data, you have to go to the Kaggle. Click this link. It will route to another place. You have to go there. Right? Sign in. You have to sign in. Sign in with the Google account or whatever you can sign in. Or if you don't have sign up, then you have to sign up. I'm going to sign up over here. Complete registration. You can register. Click that and do the registration. Sign in. Okay. Then next. And you can I agree. Then now you have signed up as a thing. So then what you need to do is you have to go to your profile. Right? So go to your profile. This is go to your phone. Settings. Go to here, go to settings and API. See here, if you go here, you can see settings. After creating your profile, right, just create your profile using Google account or anything, it doesn't matter, right? Go to settings. Then in the settings, you can see something called API, right? You can see something called API. So in the API, you have to create a new token, right? I will wait until you come to this point. First, create a profile in Kaggle, right? Then go to the settings and go to your profile here. Go to your profile here. And here you can click this and you can come here and come to your settings, right? Under that settings, if you drag down, here you can find out an API option. So now you have to create API, continue, then it will download a JSON file called kaggle.json, right? It will be in the download folder. We have to download that one to move forward, right? So download it first. If you don't download, then we can't do this data thing. They have to download. So there are a lot of data available. So for fun, you can go and download this data and you can, for example, the plant diseases, all the data are there. Plant categories, all the data. Even TVs, all the data are there. Have you downloaded? Yes. If you click that, it will go to that link. There is a Kaggle blue color point over here. If you click that, it will route you to the Kaggle and you can download. Did you download? Download it? Cool. So after downloading, what we need to do is we have to drag and drop that guy into our Google Colab notebook. So I'm going to drag this guy and come and drop over here. And on this one. Okay. Sometimes manage sessions because we have open to, I will close this one. So you might also need to do something, right? And close. Then I'm going to upload this guy over here. Drag and drop. Just drag and drop. What is this? Drag and drop here. If you bring it to the bottom, drag and drop. Okay. Then you will load the Kaggle JSON over here. Did you done it? Once you loaded it, it will show in this option. Cool. Right? So now we have downloaded the Kaggle. Again, I'm going to go to this Kaggle option and I'm going to discover the data. So now the thing is, what is this data? If you look at this data, it's a CSV file. It's a CSV file, FER 2013. Under this, you can see it's a CSV file. What is these columns in the CSV file are? One thing is emotion. So the emotion labeled up to 0 to certain values because we have seen 0 to 6 or something, it got labeled. So emotion label is here. Pixels. And it divided as a training or testing data set. So now, rather than we extract the pixels for each image and save it, the data sets itself, what they have done is, what we are going to input is a pixel to the convolution network. So they extracted the pixels and they saved those pixels in these columns, right? If you get that image, this is the data. It's a CSV file, Excel file. In the Excel file, all the 35,000 certain images, the pixels were extracted, and whether that image is angry or sad or whatever the label is given, and they have given whether it's training or testing. Clear? So then that's all we need, right? We need the pixels with the label. So we have the pixels, image pixel extracted already and saved it in the CSV file, and the label is there, and they also have mentioned it as training and testing. So uploading the images, extracting the labels, extracting the pixel, we are going to save time. We know how to do that already because we have done it in week 5. Character recognition, handwritten character recognition. We loaded it as a pixel and we have extracted the pixel numbers and we extracted the labels and put it as 1 to 0 to 9. Everything we manually did it. So in this case, we are not going to do it because they already have done it for us, right? So since we already know that, it will save some time for us. So I'm going to skip that part. Okay. So now I am going down. We are ready to run our code. First, we will run. I'll edit. I will clear all the outputs. Okay. Then I'll go here. Now I need to pip install Kaggle, right? I need to install the Kaggle into the environment. So I will run anyway. So I will install the Kaggle first. So make sure your Kaggle JSON file is added over here, right? Right. Now I have installed the Kaggle. After that, I'm going to download the data, connect to the data set to download. So I'm going to make a directory over here for Kaggle. So by clicking that, using this JSON file, it will make a connection to the Kaggle environment. So this is an API key, which will be different from me to you, to you, to you, as we have done for the last RoboFlow, right? It's an API key, unique API key to identify you. So now I made the connection to the Kaggle space through this JSON file. It's called the Kaggle.json file over here. Then I made the connection to the Kaggle database. Now I need to download the data, right? To download the data, I'm going to download it from this place. So if you go to that web page that I have loaded earlier, right? Is this Nico Let Chat Y facial recognition. So this is the one, Nick. This is the one place I'm going to download the data. Same here, I have added that part over here. Then when I click this one, it will go to that directory, download the CSV file, and keep it over here. So once you come in and open it, you can see a file over here. But this is a zip file. You can't work with the zip file, right? So you have to unzip it. To unzip this, you have to run this command, unzip facial recognition zip folder and create a new folder called facial recognition and put all these CSV file or whatever the things inside this zip folder into that. When I click it, it's extracting the CSV file from this zip folder and putting it into the facial recognition folder, right? If you go down here, the CSV file is here, right? The CSV file is now loaded into our environment. So this CSV file have 35,000 certain images, extracted pixel values, the label numbers, and it also has training or testing image, right? So that's what we have seen here. You go here, emotion labels 00542, you know what is that means? And these are the extracted 48 by 48 pixels. Numbers are here, and this is for training. If you go down, you can find out even for testing and everything. Okay. So this is a whole Excel file. So for the training, 80% of the data is used. So public test, they have used 10% of the data. So this is the data set that we are going to use for motion recognition. So now we got the data. If we have the data, enough data for CNN, that's all we need, right? The model accuracy completely depends on the number of iterations and the number of data that you are training. So number of data. So number of data means there is another thing. Number of data is not only enough. Number of unbiased data. What I mean by unbiased data? Number of unbiased data means if you only select Chinese faces for these emotions, right? Only Chinese faces for these emotion recognition. It's happy Chinese, sad Chinese, surprised Chinese, and everything. And you train the model, right? And you test that model in an Asian face, it might not perform better, right? Because it's a biased data. So when the model want to perform better and better, you have to have unbiased data for a common environment. But imagine if you are going to use this facial recognition model in China, then you have to connect the Chinese face, not the other faces, right? So that depends. That depends. So there is an issue happening in the OpenAI, crack a joke about a black person, and it gave a racial joke as an output. It gave a racial joke as an output. The ChatGPT. There's a controversial issue came. The reason because if you go to the online, most of the jokes, the racial jokes are there in the online internet are about black people. Right? So the model is trained on that black people joke already. It knows what black people joke is. So when you go and ask about that, it gave a joke. Not only that, it gave one guy asked, does black life matter to you? It said no. It said no. Because there are a lot of elements in the internet talking about black lives doesn't matter. Right? It was 1970s, 60s, that's the case. So now they have clearly identified, rectified all these data. Now if you go and ask, crack a joke about a black guy, it won't tell. It won't tell. Racially, it won't attack anyone. One thing they have strictly prompted, you can't crack jokes about any ethnicity. So it follows the rule. Other than that, they have avoided those data sets. Right? So, because of course, what we teach, the AI model learns. What we teach the kid speaks back. Right? Sometimes I go and talk my kid day. Day means it's like in Tamil we say day means younger people we call day. Come here, like that. He started to call me day. It's not a respectful way of calling an elder person. Younger person we can call like that. Right? So what we teach the kid talks back. What we teach the AI learns. That's all. Simple. So the data set could be unbiased. Right? But if you want to use it in a biased environment, then the data should be biased. Clear? Okay. And also, another issue, the data varies. So you are going to train the emotions. You use 30,000 images of happy faces and 10 images of sad faces, 20 images of surprised faces, and 30 images for some other emotions like that. And if you do the training, whatever the emotion you upload, the model will recognize as happy. Because it's only see happy faces 30,000 times. So unbiased, variable data. It should have variance. Right? In this data set, we have somewhat variance, 4,500. Discussed is less comparatively. But others are 5,000, 8,000, 6,000, 4,000, 6,000. It's a variable, different, variable amount of data. Right? So that is good enough for us. Okay. So now we connected, we download. So now what we are going to do is we are going to install the dependencies for our model training. So by clicking this installing dependencies, you will be able to install all the required libraries and everything to our environment. Here you can see there is an error with the version, but it won't harm us in the training. So just neglect those errors, right? Subprocess exited with error. That subprocess won't be necessary for our training and building up the CNN. So you can neglect that one. So now I am installing the dependencies into my platform. So now here also could not find a version that satisfies the required cracks. Version none. That's okay, right? There are issues comes in the Google Colab due to the versions, but it doesn't matter. It won't affect our thing. Just neglect that errors for now. Then after that, as usual, to build up certain emotion libraries, we have to import all these stuff. Pandas, because we are going to work with Excel file, CSV file. So to work with structured data, we need pandas. NumPy, without NumPy, you can't even imagine a CNN model, right? Keras model sequential, because we are going to build up a CNN-based network with convolution layer, max pool layer, and fully connected layer, sequential model. This output go to next, that output go to next as an input, like that. That's sequential. So we have done whatever up to now is a sequential model. So then dense, dropout, activation, flatten. So these are important parameters for our library. And convolution layers, we are importing all these things into it. And the categorical entropy is the loss function that we are going to use. The loss function, mean squared error, we have used one. After that, categorical entropy, after that we have used. These are loss function. Adam is the optimizer. Earlier also we have used for the character recognition. And these are some other libraries for the CNN execution, right? So once you upload this one, it will load all the libraries into our platform. Clear? Right. So now we will load the data set into our Python environment, sorry, Google Colab environment. So I am going to read df pd read. What is pd read? We remember, right? We gave a nickname to this panda as pd. We have done it earlier also. Read Excel files. Do you remember? Second class or third class. Read Excel file. We have used pd.read. So pd.read, I read the CSV file. So the CSV file is over here. I read content facial under the facial recognition folder. This is the CSV file I need to load. So now let's visualize the CSV file that we have loaded. So if you see here, we know the emotion labels are here. So emotion labels as we see over here. These are the emotion labels. 0 mean angry, 1 mean disgust, 2 means fear, blah, blah, blah thing, right? So if you go back to this thing, you will also identify emotion 0, 0, 2, 4, 6. And these are the pixel values of that images. And it's maintained as training image. So it's a easy way to load the data rather than downloading all the 35,000 data images into it. It will take a long time for us to download all these images. That one thing. Other thing, we have to extract the pixel values. That will take again time. And to reduce the time, you already have done CSV. We know how to do that also. We have done the same thing in week 5 character recognition, right? So now we are going to use this thing. So let's visualize the data in a clear format. So we have training data around 28,790 images, public test data around 3,589, and private test data around 3,589. All these types are in integer 64 format. Integer 64 format. That means all are full numbers, no decimal point numbers in the pixels. Right? There is no 70.534. It's 70. All are integer numbers. You know what is integer means? Full number. So it's integer format. So this is the full data set summary. So now what we need to do? We have to split the data into a training data set and the testing data set. In this CSV file itself, they have labeled as training, testing, certain images as training, certain images as testing. So what we need to do is go through the data set and extract the training images separately, testing images separately. By executing this code, xtrain, ytrain, and xtest, ytest will be separate. Right? So we are going to go through the Excel file, identify this training label, separate it as separate, testing label, and we are going to separate it as for testing. So by
Now we have done it as training and testing labels separated completely. Now we are going to define the training parameters, right? So now we are going to number of features, 64. We are going to define the features which are specific, the number of input features or dimension per data instance. Number of labels, there are 7 labels, angry, sad, happy, disgust, like that. There are 0 to 6 labels are there. 7 labels. Batch size 64. You know what is the batch size? There are 35,000 images divided by 64. We are going to take that batch, one batch, put it into the one epoch. Randomly select another batch, divide 35,000 something divided by 64, put it into the tree, right? So now they're not 35. We are going to have 28,709 for the training, right? And epochs, how many number of iteration you are going to go on? What is the size of the image? 48 by 48, right? So now we are going to define that features over here. Number of features 64, 77. Epochs you can train it for later higher numbers. Since we have less number of training time, we'll use 10 for now. Later on, if you want to train it for 100, put it and it will take a longer time. So I just put it for 10. Okay, in home you can write. Then what I am doing is, I am trying to put it into a float format. Earlier, all these numbers are into the integer format, right? All these numbers are into the integer format. I am changing it into a floating format. Why? Because I am going to do a convolution. When I am doing the convolution, there are kernels, right? The kernel filter. It has point form number. If you multiply a full number by a point number, there might be a point number output. So if it's an integer, it cannot handle the point number. So what I am doing is, I am changing all these train data set, test data set into a floating point number. Then when the kernel is going through these pixels, a point number is the output, decimal point number is an output, it won't be a problem. If you keep it as an integer number, it will give an error because the output is a floating point number. It don't know how to handle it, right? So for doing that, I'm just changing this format into a floating point number. Clear? Right. Then after that, I am defining the categorical label conversion. So now we have angry, sad, and everything into these class labels. So that is fine. After that, reshaping, standardizing, all these values are, the max divided by min, right? So we have to standardize. Earlier we divided by 255 for the character recognition. But here there might be not dark images. 255 is pure white. Sometimes if you go here in these images, do you identify any pure white? I don't think so. Not pure white. So there mean 255 is not the maximum, right? There we divided by 255 because they are a pure white. In these images, they are not, maybe not any white images. So what we did was, we find out the mean deviation and we did the standardization using that, right? So that means we are getting it to 0 to 1. So 0 to 2555 is the pixel. We are getting everything to 0 to 1. What maximum value is 1. Minimum value is 0. So we have done it in the character recognition as well. That's the standard format. When you are working with images, you have to standardize, right? So that is clear. Then we are ready to build up our first convolution layer. So I just put the batch normalization into a comment because this, you can run it later on when you are going home. Delete this hash mode, then it will become active, right? This will become active. The model batch normalization might improve the accuracy, right? But now I'm just keeping it. Every batch, you get an output. Batch normalization means what? Now you have normalized input, right? You have a normalized input pixels. Then the kernels go through this and another output is produced, right? That is another matrix. Then that matrix is not normalized. So that matrix have different values. So batch normalization means that matrix also you normalize. And that normalized matrix goes to the net convolution. Every batch you normalize and put it into an input. If you idle it, only the output will go directly as an input without normalization. Only the input is normalized. The output of the first convolution will not be normalized. If you eliminate this hash, the output will be normalized, and that input normalized will be go to the next convolution as a thing, right? So it might give a improvement, right? You can try it out in home. So the first thing, I'm having a 64, kernel size is 353, activation function is ReLU, and second convolution I'm adding 3 by 3 ReLU, and again I'm adding a max pooling layer and model output dropout. Dropout means certain values we drop out to make it faster, right? So I'm going to execute, created the first convolution layer. And the second convolution layer coming up, again I'm adding 3 by 3 kernel, model convolution 3 by 3 kernel, ReLU is the function. Max pooling in what? Reducing the size, right? Convolution mean kernel goes through that, finding that. Max pooling mean you go through a max pooling layer, find the maximum and put it there. So if you have 48, 48 matrix, it might come back to 30 by 30 matrix, reducing the size, right? So that is also I'm running second convolution layer. Third convolution layer, again the same 128, 128 and model max pooling and everything. Then I just do that. And after these convolution layers are done, what is the other one? Classification. That is a fully connected layer. What we have done in the character recognition, max pool, convolution, max pool, convolution. Finally, we added the neural networks, right? We added the neural network for the classification. So that is this one. So I am dense layer 1024 neurons and the second layer 1024 neurons. And the output will be number of labels. So like now we have a lot of inputs. First convolution layer that have a lot of convolution, output, second convolution, third convolution, output is 1024 neurons, 1024 neurons, and output is 6, 0 to 6, right? So totally 7 neurons. Why? Because here we have SAD, we have P and 3, 7 outputs, right? So here 1024. 1024, and these are the 3 steps of convolution. So you have 48 by 48 pixel is going to go in, and convolution, output, convolution, output, input of convolution, right? This is the model architecture. So when you run that one, we connected the last layer as the classification layer or dense layer or fully connected layer, all are the same words, okay? So now you can see there is a convolution layer, there is a convolution layer and a max pooling layer. That is in the first convolution part. Second part, I'm dropping out also. In the convolution 2D, again, see the size. Here 46 by 46 after that first convolution, 44 by 44. Then the matrix size reduced to 22 by 22. Then I'm dropping out certain values, but dropping out means certain values are changing to 0, right? So then 22 go in, then the convolution gives 20 by 20, third convolution gives 18 by 18, then I reduce the max pooling 9 by 9, right? 48 by 48 came to 9 by 9. Again, I'm not doing it, I'm just 9 by 9 going in, second after another convolution 7 by 7 matrix, another convolution 5 by 5 matrix, after a max pooling, the final output is 2 by 2 matrix. 2 by 2 matrix is going into the flattened layer 512, 1024, 1024, 1024, 1024. See, these are dropouts. Okay, dropouts. Finally, output is 7. Clear? Right? Clear. So you can ask how the 2 by 2 matrix will be flattened into 512. 2 by 2 matrix means 1, 2, 3, 4 values, right? So, but we have 512 neurons. What happens? It will be automatically filled with zeros, right? The rest of the neurons input is 0, right? So, we can change this architecture to input 4 neurons and 1024, 1024. That is also possible, right? So, you can play with the model here and change the accuracy and test the accuracy. As I said, how I came up with this model? I just came up. Right? Nothing else. So you can test and train, and you can come up with the good model which give the highest accuracy. So these are called hyperparameter tunings, model parameter tunings, right? Model architecture tuning. Okay. So now we come to that. So total parameters, weights and biases that we are going to train is this much. total trainable parameters are this much and non-trainable parameters 0. So this is the model compiling parameters. Okay, I'm going to use categorical entropy loss function, Adam optimizer, and the accuracy is the metric that I'm going to measure. Now we will start the training. Once you start the training, it will start because we have defined the number of epochs as 10 earlier. So it will start. So it will take a while to do the training. But you know, if you want more accuracy, there are two ways. You can increase the number of epochs to 10, 50, 100 and you can test it. Or otherwise, change the model architecture. Right? Have multiple convolution layer, reduce the max pooling layer, reduce the number of fully connected layer. Completely up to you. Finally, what we need? A good model which can recognize emotions. Right? That's all. So now we are training 6 epochs. It's pretty fast because we are connected to GPU. And the image size is 48 by 48, very small. And when it's come to output, 4 by 4, exporting output, right? Then the fully connected layer take it in and classify. So there are many zeros. So it'll be fast, right? If there are many numbers, then it will take a little bit of time. So you can play with that model architecture, change the model architecture, change it fully connected layer, and try to do it. So now we are training it out. You can see 9 iteration is going on for me. What about you guys? Okay. Is it done? Now we are at the edge of finishing the training. We have successfully finished the training of this emotion detection model. So now the training is done. After that, what I'm going to do is I'm going to save the model. So unlike last time what I have done, I saved 2 models. What? Best model and the last model, right? This time I didn't do it, right? I just, because it takes some time to save back and get it time to reduce the time, I didn't allow that checkpoint. I'm going to save only the last model, which is true. Only the last epoch model I'm going to save here, right? To save it, I just need to click this one. So you can see 2 saved models, a JSON file, FERH5 is the model trained one, a JSON file also saved. Why last time we only saved one H5 model file, right? Not the JSON file. This time, the JSON file we are saving, that is the architecture of the neural network model. We are saving that also, but it's not necessarily for us to save over there. Okay, the architecture. So, which is in the human readable format. You can open it up and see. So, class name sequential, all the data related to these things will be there. Okay, so it's architecture file. So if anyone asks what is the architecture of this model, you just need to send the JSON file. So they will be able to identify what are the classifier, what is the configuration, everything, right? So you can download, let's download and see. Download. If you open this one, it might be a text file, you can see here. Open. Okay, class name sequential, configure name sequential, model name Keras. Okay, this is the Keras version that I have used, and TensorFlow is the model thing. So like that is a model, nothing else, right? So this is a model parameters that you use it, because when you are working as a collaborative environment with multiple people, they don't know what type of model, what type of library, what is the version of the library that you have used. Nobody knows. So if you send this one to there, they will understand, okay, this is how you have created the thing. So this is a model summary. These are the weights. .h5 are the weights which we have trained. This is a trained model. So now we will evaluate the model, okay? How the model is trained and tested. Let's say we will evaluate the model. By clicking that, it will tell you the training accuracy and the testing accuracy. Now, if you go there and see, the train loss is this much. Loss is really high now, right? Loss is really high. Train accuracy is 61 point something. Not that accurate because
We didn't train for higher number of epochs. If you train for higher number of epochs, then it will be good. The testing loss is 1.18. Again, it's high comparatively for a CNN model. And the accuracy is 54. Not enough, right? Not enough. 54 means 50-50. It's not good enough. So what you can do, go home, increase the number of epochs, train for 80, 90, 100, and test the accuracy. If it doesn't change, you know what to do. Go, change the architecture, add some more convolution layers, change the architecture of the fully connected layer, and do the training again, do the testing, and you can bring it up to 80-90% by doing that simply. Okay. So now the train model only shows 54.10 thing, right? This is the accuracy of our train model. What about you? The same value or 54.10978? 55. So it will different. It depends. You know, that's the initiation of the weight. That's how AI works, right? Now it's okay. For me, it's 54. Then there is a thing called, to visualize this testing, we use a matrix called confusion matrix. What does that mean? Confusion matrix. It really confuses. Let's see. I will click this code and there will be a matrix comes up here. This is called confusion matrix. What do you understand by this? It's really confusing, right? That's why it's called confusion matrix. No, just kidding. So what is this reading is, okay, 0 is angry, right? So when you put the angry images into the model, the train model detected 207 angry images as angry. Correctly. 26 of the images, angry images, are detected as label 1, maybe happy. Right? 73 of the angry images are detected as sad, label 2. So 32 of the images are detected, angry images are detected as label 3. Right? Like that. So if you see label 1, let's say what is the label 1 for us? The label 1 for us is over here. The data set is disgust. And label 2 is fear. Label 3 is happy. If you come back to the confusion matrix, let's say label 3, that is the happy. So out of this total, this is the total image testing images, 64 of the images, happy images, are identified as sad. 4 of the happy images are identified as disgust. 56 of the happy images are identified as something surprise or something. 721 images are identified as happy. So that means it's a good happy face detection. So like that, by looking at this image, you can identify this model will more or less detect the happy versus correctly. Right? Because it's 721 images are detected happy. But if you see this one, out of disgust is also good. 8 of the images, disgust images, are detected as 8 as disgust in the testing. So like that, you can identify how the model is trained and performing in a better manner. Rather than showing this accuracies, you do not have any clue. It tested and it giving the number. But to get it in a very nice way and visualize, okay, how the model works, confusion matrix is a one way. Okay. So now you know what is the confusion matrix. It does not confuse. It gives the right clear picture to you how the model performed on certain test images. Right? For example, if you take the 6, that is the surprise or something. This 6 is detected as 6, 346. But there are 180 images as labeled 4. So that means this is not trained well for the label 6. Right? So then you can do the training and you can test the confusion matrix. Now let's test the model. We have trained the model. Let's test on our images. So let's say def emotion analysis. I am defining a function. So these are the angry, disgust, fear, happy, sad, surprise, neutral. These are the labels of my detection. And these are the percentage and everything. So I am defining a function to visualize. Now, what I am going to do is, I am going to upload an image here,
right? So let's say I will upload an image of what we have downloaded earlier. Maybe Cecil sir's image. We'll use Cecil sir's image. One image over here. Okay, I'll load it. Okay, I'll load this image over here and put it here. You can download even any images that we have downloaded for facial motion recognition. Maybe another Cecil sir's image over here, and maybe another couple of images we'll do the testing. Okay, maybe my image over here. Okay, so like that. So we'll test it in the three images, how these things going to work. So now what I'm going to do, we have to change this one. I'm going to go first Cecil Kumar Avadu's photo I have uploaded. I just click, oh, test one PNG, I clicked it, copy path, right click on the image that you have uploaded, copy path, and you paste it in this inverted comma, right? Then you click play. Once you click play, the emotion of Cecil sir is detected as this 0.15% angry, 0.123% or something fear, but it's 0.4% happy. So the final label will be happy, right? Okay. Now let's detect my image. Go copy path, and I replace over here my image over here and play. Then you can see my image is again happy. It's detected as happy, right? And there is another image of Professor Cecil. Copy path, and I go there and I will do that and paste it. Let's see. Again, this is mentioned is as happy. You can see the person. Shall we test something as angry? We'll go back and we will download some images, angry images, angry face. Okay, so I will download this image, right? Let's see how it detects. Save images, and I will save it as JPEG in the download option. Save, right? So I'll go back again to my model and the emotion detection model. Go back, and I'm going to load this person over here and copy that path, and I'm going to replace it over here and run it. Let's see what is great. Again, it's detecting it as happy. What do you think? What is the issue now? In the confusion matrix itself, you can see this 721 is dark. That means that model is trained, but now while training, it didn't fully train. We stopped at 10 upwards. So it's trained on happy faces more nicely to detect. So still, if you see here, it detecting as emotion is as happy, but this is an angry photo now, right? Let's see some other images. Maybe the teeth is showing over here. This is angry, but 48 by 48 pixel. When you are happy, you show your smile, right? So in this pixel, if you see here, she is showing her teeth, right? It might detect it as a happy. Let's find another image which is not there, which is not showing the face. Okay, maybe this one. Save images. Okay, downloads. Save. Okay. Then I'm going back and going back to my emotion detection. Upload the image of this person over here and copy path. I'm going to change it over here. I hope it will detect a different label. We'll see. See, there we go. It's detected as neutral, higher, right? Because the face is 48 by 48. Another disadvantage that we have is 48 by 48. What you can see here in this 48 by 48 pixel, nothing, right? So the feature limitation is also there. Why we selected 48, 48? Because we can't train a model for 198 by 198. If you want a very advanced model, do the training in an HD image. Then it will be more accurate, right? So that's depends. So in our class, this is the accuracy, but still you can improve it by increasing the number of epochs, changing the model parameters, you can achieve a better model. Clear?
So now we will take an image and see how our face looks like right now. Maybe I believe like every one of your face looks like confused. What the hell is going on? Let's see, okay? That how the model take. Okay. So to do that, we need to install the Keras TensorFlow libraries. So I installed it. After that, I'm going to run this code. Okay. So when I run this code, it will turn on my camera and I'm going to look like, okay, an angry face. I'm going to put it over here and see. Okay, let's see how it detected. Okay, I took a photo, angry face. You can also take a photo with an angry, discuss something faces. Now this model will perform very bad because we didn't train it for max number. Obvious, right? So after detecting the photo, we will scale it down to first, another thing. Now we detect the photo, we detect the image. After that, what we do? We have to detect the face. You upload the image, first it need to detect the face, right? Then only it can identify the emotion because our emotion faces, the training data, we only send the faces. So I need to detect the face from my photo now. So by doing that, I will detect the photo, my face is detected and reshaped into 48 by 48 into grayscale image. Okay. So now I'm going to load this my train model. Already my train model is saved over here, and I'm going to test the image that I have took now. So let's see. It's a neutral, but it's not neutral. Maybe this looks neutral. I don't know. Maybe the model detected as neutral. It can be improved, by increasing the emotion. So if you want to do it again, you can go back again and take an image. Let's say I'm going to smile. We'll see. Nope. Here. Right? Taking an image, going again. I'm going to take an image with a happy face. Okay. Then I'm going to reshape it to 48 by 48. Detect the face. Here also I am detecting the face using Hascade method. The method that we have used for the face detection in the previous, right? Hascade method. Then Har Cascade, right? Har Cascade method. Then I reshape the image and put it over here. Then let's test the image now. See, it detected correctly. Why? Because it saw the teeth happy, right? So let's see a discuss face. You can play with this, right? So there is another way we can do in the Google Colab. Turn on the camera. In real time, you can change the face. It will be able to do. But there was an issue happened in the last, the library upgrade or something. The video camera is not accessible when I am running that code. So it's a frame not captured, from not captured image. But let me check if I found it, I will upload. So in the real time means what? It doesn't real time. We take a frame, analyze, put the label. Take a frame, analyze, put a label like that, right? So you can see it's video is not continuous. Like here, like it's like a frame-based detection, right? So that's how. Even in the cars, Tesla car, while you are driving, it's not running, doing the object detection in real time. It's doing the object detection in every frame. Every millisecond, it take a frame, detect the object. Next millisecond, detect an object. Maybe not even millisecond. It can be, millisecond. 10 millisecond, every image detection option. 10 millisecond, every image detection option. Like that, you can also do it over here for the facial emotion recognition. Is that clear? So why we didn't do the CNN based training for the face? Because it's not practically feasible. Every time you have to do the damn training and you have to have a lot of data. Not feasible for attendance system, right? But the emotion, it doesn't matter. I trained in some data set, but when I am happy, detecting as a happy face because the facial expressions are the same for everyone, right? It might vary. If you train in Japanese data set, biased data set, and come and say the Japanese eyes are very small, our eyes are very big compared to them. So model might confuse on emotion recognition, right? So this is how. So where we use the emotion recognition model? In hospitals to identify the pain level. So when you go to a US-based hospital, unlike in Sri Lanka, you don't want to wait for the doctor. There, the doctor wait for you. So come there and they call your name outside on your appointment time. So Logi, then we go inside and they ask about your medical history, everything, and they per patient minimum 20 minutes spent. Whatever the disease you go for, minimum 20 minutes they will spend. One doctor. Here you go in, next minute you come out, right? And you have to wait for 1 hour for the doctor to come in and as a god, and that guy come in without even a guilty feel. Get into the thing and he act like a god. Even in private hospital, that happens. I never like to go to a hospital in Sri Lanka because of that reason, right? If you want to go to a hospital where the doctors come on time, is KD hospital, right? Doctors are on time because if they are late, they might go through a punishment or something. I'm not sure, but KD hospital, they are on time, right? If they are late, they will inform you in mobile phone through a message. Doctor will be late by 30 minutes. So this is the thing, right? So that's the thing. So when you go to the doctor asks in US, okay, I am having a pain over here. Means, so there is a rating. Explain the number 0 to 10 level of pain, right? So we say it's 5 level. Out of 10, 5 level of pain. Out of 10, 6 level of pain I am feeling. So they rate the pain. So due to that, they also implemented a face recognition, emotion recognition model similar to the pain recognition. So if you see pain, if you less pain, your face will be little shrink. If you see more pain, you show a very painful face, right? So the model will be able to recognize the pain level based on that. One thing where you can use the emotion-based recognition for the pain recognition model, right? Other thing, we are right now working on a model where AI interviewing system, the HR, completely the HR workforce will be replaced by that AI system. So the AI will automatically select all these CVs based on the job description and send a link for the first selected 50 CVs or something, but we define in the system. When the people open up the email, congratulations, you have selected for the initial screening test. So when you are ready, click this link to attend the interview. Right? Then you turn on click the link, an avatar will come up and the video camera will be turned on and the questions will be asked by AI. Right? Then you answer. While doing that, your emotions will be recorded. Right? Still, it's not completed. We are trying to integrate that emotion recognition into that system. And where else? Lie detector. Right? So lie detector is a thing you connect here. At the same time, through the facial expressions also you can identify. So lie detector. There are a lot of places the emotion recognition works. And in, yeah, that's another thing. I supervised, not me, one of my professor, like colleague supervised a project, elders home in the like, how to say, disabled people, differentially able people. So these, how to say, their facial features are different. So like how to say that people, I don't know how to name it. Differentiable people. They are differential, not legs, hand are okay, but they are not mentally well. So their facial features are different, right? You can see. So mentally disabled people, I can show you. So like this, their features are little different, right? So they are little different features. So the common features of a person, how they are happy, how they are sad, it's little bit different from the common human. So one of the person have identified, built up a model emotion recognition of these disabled people in a home, in a shelter. So they can point out that camera to that person and identify what that person, which mood he is in, because their faces are totally different, right? So in that case also it have been used. So there are many practical examples the facial emotion recognitions are used. So yeah, so I hope you understood what the emotion and the face detection and recognition models are, right? So next, the voice. So you thought those are big techniques, right? But it's a very simple technique that you're using for everything. If you know CNN, if you know how the ML works, the very basics for everything we are going to use. How the voice? How the voice is going to work? Voice is not an image. Voice is not an image. Image we know now how to do that, right?
So how to do the voice? Think about it. Next class we'll learn about it. So voice is not an image. We know how to do the pixel values now, emotion, face, everything we played with the pixel. But voice is not an image. How we are going to deal with that data? Think about it and come. We will discuss next class. Okay. All right. Until then, thank you. If you have any question,
You can ask me or else you can find out the same. So now you have a confidence to build up any kind of model, right? CNN model with the image, any image, right? So there are certain things we can do nowadays. So now what we are introducing here is the principle and a certain kind of library. A certain kind of library. But don't think this is the one and only library over there to do the task. Task cascade method is one way to detect the. There are multiple other ways available to do that, right? So maybe it might be better but slower. Sometimes it might be faster but not better. Depends on the scenario, right? For example, what the Haas cascade done today is, he was not able to detect Mr. Jason is now his photo faces because when it ran through the filter, it couldn't find the facial features in the image due to the lighting or maybe due to the sharpening or editing of the photo that we have done, right? So that makes sense. All right, so then we will meet next week and we will see. Any questions? Yeah. Yeah. That's due to the library issues that I tried actually working the Google Connect, which I forgot those. I tried. So we saved the model somewhere, right? Yeah. We have to load it and we have to paste it. Let me do it. So now you can go and build up your own attendance system. And you can fake an attendance system.